Hi everyone, I'm Jin-Hwa. I'm very happy to present my recent work. This is collaboration with Jae-Hyun and my advisory professor, Byung-Tak. Assume everybody knows the task and the dataset, but please notice that the VQA score is the average of the 10 choose 9 accuracies, effectively as shown in this table. It's a bit confusing to newcomers, but it is crucial to fair comparison and the validation score reports. Please keep in mind that. Bilinear attention is to give separate attention to every interaction between the words and the visual concepts. Since these interactions have different meanings, it is natural to map a token dog to the dogs in an image and cat to cats in an image. So, however, a naive approach may introduce a huge computational cost. So, we propose an efficient method with the same time complexity on top of low-rank Bilinear pooling. Moreover, lateral learning of attention gives an efficient way of integrating multiple attention maps instead of a naive concatenation of each joint representation. And we will show how we integrate the counting module. For this, we use all hidden output from GLU, which means that we use the context from that. The number of embeddings are equal to the number of tokens in a question. Following the previous work, we find the 10 to 100 objective features using bottom attention. In our previous work, MLB, we proposed low-rank Bilinear pooling using low-rank factorization of a bilinear weight tensor to efficiently get a joint representation, which can be used in attention networks. The attention network uses the question embedding vector as a query and combines multiple image features using the calculated weights by the query. We call this way a unitary attention. Bilinear attention maps. For the bilinear attention maps, we use matrix chain multiplication with a key trick involving a projection vector P and element-wise multiplication. I think this equation is the key idea of this work. We can show that the single attention logic is acquired exactly in the same way of unitary attention mechanism of MLB, our previous work. Interesting. Multiple bilinear attention maps are acquired by different projection vector PG, and other embedding matrix may be shared by across the multiple attention map. Then a bilinear attention network uses the attention maps like this way. This is a bilinear model. Each multimodal joint feature, Fk, is filled with these equations. In the implementations, broadcasting lets you implement this seamlessly without for roof in the code. Again, this shows that the same mechanism with MLB, but for bilinear attention. Note that the low-rank bilinear picture learning is inside of bilinear attention. Similar to MLB, activation functions can be used. We use the value in this way. This shows that schematic figure of the model. However, for the correct interpretation, be careful to examine the proposed equations. This is just a schematic diagram. And time complexity is the same with the unitary attention with the VQA setting, since it remains as a matrix chain multiplication. Furthermore, we propose lateral learning of attention in this way. Please notice that the repeating operation, the position of repeating, to match with the dimension with the input F. This is an overview. Maybe you can check in the poster or in the archive paper. Surprisingly, 8 glimpse models is our best. They keep increasing the performance in our experiment. And the residual learning is better than any other methods like summations and concatenation. And this way is way better than co-attention. We compare with the co-attention and just unitary attention. The left figure shows that in the learning curve, the blue line shows that the bilinear attention gives more regularization over the others, whereas co-attention overfit more easily than unitary attention and bilinear attention. In the right figure B, 4-glimpse model is more parsimonious than 1-glimpse model. This is the interesting part, but unfortunately, MFB is not significantly different in our experimental setting. The visualization for 2-glimpse bilinear attention network, you can see that the asymmetry in the bilinear attention maps, and generally content words are attended, and due to residual learning, the minor differences are observed. For each bilinear attention map, we use max out along with token axis as a multinomial distribution for object duplication proposed in the counting module, which is proposed by Zhang. This paper is presented in this year's iClear. I think this work is very amazing. It used differential functions and easily integrated with our bilinear attention network. Except this, nothing is different from the proposed work. This is a single model research on test step score. Bottom of image picture remarkably gained around 30%. And the bilinear attention gains over co-attention and MFH around 0.